Hello students, welcome once again to this section. In this section we are looking at absolute and relative error. Now this is a third series of absolute and relative error, so let's quickly do that. Now we are to calculate the absolute and the relative error with the exact value to be determined at 5 digits, right? And we are to consider 4 digits rounding. So we know that the absolute error here in the case of the floating rounding is giving us just a float round of these values, right? So let's say this is a, right? Let's consider that one to be a here divided by that of b, then minus a divided by b here. That will be the absolute error of that, and the relative error here is going to be the floor round of just a divided by b, then that of a divided by b here being divided by the absolute of a divided by b. Now, so that's what we are going to do, but first we have to find the floating round, right? So the floating round of just a divided by b is given by the floating round of the floating round equal to, so we have the round of a then divided by the round of just b, right? So this is what we are going to use, but first we said that a equal to 5.291, so that's what we are calling a to be that, and we are calling b to be 0.003000. Now if we are to calculate the absolute and relative, so therefore we realize that before we can find the round of that, we have to calculate for this before. Now the floor round of a, we have to find the floor round of a. So the floor round of a here, so the question says that we should round it to about 4 digits rounded, right? 4 digits rounded. So 4 digits rounded will just be 5.5291 times 10 to the power 1, right? And over here the floor round of b is just going to be 0.003 and 0, right? So that's the 4 digits rounding. Okay, so what we are going to do next is substitute this into the formula over here. So the floor round of we have a divided by b is just equal to the floor round of that, then we have 0.5291 times 10 to the power 1 being divided by 0.0030, right? And when we do this, we'll just get so when we compute this, we are just going to have 173.35, and we have to find a floating round of that. So we round this to about 4 digits, right? So in 4 digits we are just going to have 0.1763, right? 3 here, then times 10 to the power we have 4, right? Because we have to times 10 to the power 4 here. So when we do this, we are going to get 6, right? So when we round it, we are going to get 0.1764 times 10 to the power 4, right? Now since we have this, now we can therefore compute the absolute and the relative error, but then also we need a here being divided by b, right? So let's do that. So a divided by b is basically we're looking at the 17a is just so a here is just 5.291 here being divided by 0.003000. Now when we compute this, we are going to get 176 1763 here point 1764.6666 think 56 and then 7, right? So this is what we have. Now all we are going to do now is to compute the absolute and the relative error now. So the absolute error is given by the floor round, right? So the floor round, we add the floor round, right? The floor round of A and B, we have it as over here as this, right? So we are going to substitute that into it. So we have the floor round, the absolute of just 0.1764 here times 10 to the power 4, then also minus just the A divided by the B. So we have 176 here, 4.66667 absolute, and the absolute error here is just going to be remember it's absolute, so it's going to be positive 0.66667, and that will be our absolute error. Now what about the relative error, right? So the relative error is also the floor round of that, so 176.4 here times 10 to the power 4, the minus of 176.4 here, 66667 here, right, being divided by the absolute of A divided by B, which is just that, so 176.4.6. so we have that, and when we compute this, then we should get negative, but because of the absolute we are going to have positive, so 3777 times 10 to the power negative 4. But then also the question says we should run it to the question says 5 digits, right? So 5 digits, so we are going to get so we are just going to get over here the relative error being equal to 0.3777, right? So let's leave it this way, yeah, or we can still add another 0, so we can do it this way, 0.03777, right, times 10 to the power, and remember it's going to be 2, right, 2, yeah, and that will be for the relative error. So thank you very much for joining me in this section, and I'll see you in the fourth series of relative and absolute error.